If you have seen white paper or fabric rolls cut into smaller width rolls or cutting of big metal rods, you might have wondered how many ways there are to cut a big stock item into small pieces of required lengths. The answer is too many ways. Perhaps a better question is how to cut required small pieces from the stock item so that waste is minimum. Another question you could ask: how to cut the required small pieces from the stock items so that minimum possible stock items are used. This problem is called cutting stock problem, and it is studied under a subfield of applied mathematics called operations research. People in metal, glass, paper, and textile industry deal with this problem every day. If each next piece that we want requires a single cut to get, it's called 1D or one-dimensional cutting stock problem. Examples include cutting of paper rolls, fabric rolls, and metal rods. If cutting involves a rectangular sheet cut into small rectangular sheets of required sizes, it's called 2D or two-dimensional cutting stock problem. Examples include cutting of glass sheets and metal sheets. This video discusses 1D problem in depth, and in the next video we'll discuss the 2D problem. For the sake of example, let us assume that we have standard rods of size 89 centimeters in our stock. A customer order arrives and it says they need one rod of 45 centimeters, one of 25, three of 20, and one of 35 centimeters. We immediately start cutting. We don't think of rearranging the rods, and we cut them in the same manner that they were mentioned in the customer order. From the first stock rod, we cut 45 centimeters and 25 centimeters, and we are left with 19 centimeters, which does not satisfy any of the customer demand. We move to the next rod for cutting. We cut 20 centimeters, another 20, and another 20, and we are left with 29 centimeters. Our last required rod is 35 centimeters, which cannot be cut from 29, so we have to cut another stock rod. We start cutting third. We cut 35 centimeters and we are left with 54 centimeters. So with no planning for cuts, we ended up using 3 stock rods to satisfy the customer demand, and our leftover is 19, 29, and 54 centimeters. We might be able to use the leftover 29 and 54 centimeters rods in some future orders, but 19 centimeters leftover will most likely go to waste because seemingly no customer needs rods less than 20 centimeters. This no planning for cuts is certainly not ideal. What if the next order requires a 60 centimeter rod? We cannot satisfy that with 29 and 54 centimeter rods. So is there a way to satisfy this customer demand so that we use minimum possible stock rods and our waste is minimum too? Let us plan for cuts with the help of a tool. I designed this simple tool to solve cutting stock problem, which is free to use and available at alternate.parts/CSP. The CSP tool can plan both 1D and 2D cutting stock problem. Let us focus on 1D tool, which helps us in finding an optimal plan to cut our stock rods or stock fabric rolls so that minimum possible stock is used and waste is minimum too. Here you see 2 tables. In the top table you specify the details of customer rods to cut. In the bottom table you enter stock rods details. Notice that you cannot specify the quantities of the stock rods for now. Actually, this tool will tell you how many stock rods will be required to completely satisfy this demand. But I might add this feature soon so that you could limit the number of stock rods to be used and satisfy maximum possible customer demand while staying in the limit that you specify. Let's enter the sizes of customer roles in the top table. 45, 1, 25, 1, 23, 35, 1. Enter size of stock rods in the bottom table. 89. Notice that you don't need to write the units like centimeters or inch. You only specify size in number. Click Cut. And here in the diagram on the right, we see the plan of how to cut the rods. Each row specifies one stock rod and each box represents one small customer rod. Rods with same width or size have same color, and the blackish color specifies the waste or the leftover part of the rod. In the bottom right table, we can see the usage or utilization of each stock rod. First rod was utilized 95.5% and 89.9% of the second was utilized. And here is the detail of the cuts. You can also download these cut details in a CSV file and import to Microsoft Excel, or simply copy and paste to Google Sheets. Let us see how CSP Tool works behind the scenes. It uses Google's OR Tools library, which is a fantastic library to solve problems like cutting stock problem and other operations research related problems. OR Tools is very straightforward to use. You specify the variables. Variables will contain the results of your problem. In our case, they will contain the number of stock rods to be used and the plan of cutting. Then you specify the constraints. Constraints are limits within which your algorithm must find a solution. In our case, the constraints are that all the customer orders must be satisfied and sum of sizes of small rods cut from a big stock rod cannot exceed the size of the big rod. And then you specify the objective. The objective is what is your main goal with this algorithm. Like our goal with CSP is to minimize the number of stock items used. The code for this algorithm is available on GitHub at this URL. I'll put this link in the description. If you don't understand this programming part, no worries. You don't need to know programming to use the CSP tool. Just a reminder that CSP Tool is free to use and available at alternate.parts/CSP. There are a few limitations to this tool at the moment. It only works with natural numbers. That is, it does not work with decimal part. There is some bug in the code which will be fixed soon, but it introduces some extra small items in the result. If that happens to your results, the CSP tool will alert you about it and you can exclude those items. Okay, enough of theory, let's do some cutting. Here I am cutting class sheets for the sake of example. Class sheets are usually cut along 2 dimensions and hence part of 2D CSP. But I am applying 1D for demonstration purposes. So I took 2 slabs of glass and I would treat them like rods, hopefully. Both rods are 89 centimeters and I want to cut 2 rods of 30 centimeter, one of 25 centimeter, 2 rods of 20 centimeters. I inserted my desired dimensions into the CSP tool and it gave me the cut plan. Google's OR Tools library was used in making this tool. They have great tutorials available and examples that are easy to follow without any background and operations research. It is available for Python, C++, Java, and C#. I also learned a lot from Professor Sergey Kruk's book, Practical Python AI Projects. It is very easy to understand and totally recommended. In fact, most of the code used in our CSP tool is taken from this book. The 2D cutting stock problem is even more interesting and challenging to solve. If you want to learn 2D CSP, please consider subscribing. See you next time.